Alright, the last video was about square roots. This video we're going to do some cube roots, and then I'll go over just a couple of key things in, I think 7, 8, 9, and 10, just to kind of help us answer some of these in the workbook, because those are some of the harder ones, and we haven't gone over this yet in class. So that's why I'm uploading a mini lesson to help you guys out, in addition to the con examples and the con videos that would help you out too. So the cubed roots are very similar to the square roots. So remember, the square roots, we started off with a square, and all the side lengths are equal, and I'm just going to say it's going to be x. But a cubed root, instead of the square root, we're going to draw a cube. And what's special about a cube is all the lengths are the same. So that's the same. This side length is going to be x. This side length is going to be x. So if that side length is x, all the other ones could be the same. Does not matter what. And the square roots, we are working with the area. So I said like the area was 30. And we're trying to figure out what each of the side lengths of the square was. Well, cubed roots is very similar. We're going to try to figure out the dimensions of the cube. But instead of area, we have 3 dimensions. So we work with the volume. So if I say the volume of this cube is 125 units cubed, is how we would call it. I'm just going to write 125. Then we know that defined volume is x times x times x, x times x times x, and that will equal 125. We also know that x times x times x, we can write like x to the third, and that equals 125. So right now, all I did was find the volume using my side lengths. So the side length is just x. All my lengths are going to be the same because it's a cube. But to figure out what x was, it's very similar to the square roots. We have to undo this power right here. The last one, we had a power of 2. So we could undo the power of 2 by getting the square root. Well, we can undo the power of 3 by doing the cubed root. And the cubed root looks like this. Very similar to square root, except there's a 3 in that corner. So we're going to undo this to get x by itself by doing the cubed root of x to the third. And that just equals x to the first, or x. And we have to do the same thing to each side. Okay, so the cubed root, 125. And I'm just going to rewrite that right here because I'm not sure what that is yet. Pew, pew, pew. Just like that. Okay. Cubed root of 125. So we had the volume, and I want to figure out what side length is, and we got the cubed root of 125 after we got x by itself. Alright, but I don't know what that number actually is. Yeah, I know that's going to be the right answer, but what in the heck is that number? So how we can figure that out is, just like we did the square roots, we're going to have to figure out, well, I know I multiplied 3 of the same somethings and got 125. I have to figure out what those somethings are. So in all of these, we're going to do the guess and check method. Okay, guess and check, meaning you guess a number to multiply with here and see how close we get to 125. Well, I'm going to guess 4 first. So let's see what 4 is at. Just because I need a starting point. Let's see, 4 times 4 times 4. Does that equal 125? That's our guess. Let's check it. So 4 times 4, 16. 16 times 4 is 64. Oh, so it's not 125. It's less. It's 64. So since our guess of 4 was not enough, it gave us an answer that was too small, I need to up my guess. So I'm just going to up it by 1. We start at 4. Let me up it to 5. So we know that 4 was not right. It was too small. So I'm going to guess 5. 5 times 5 times 5. Does that equal 125? Well, 5 times 5 is 25. Times 5. 25 times 5. Well, 25 times 4 is 100. Plus 25 more. So 125 times 5 is 125. Whoa. So 5 times 5 times 5 is 125. Check. So that means our guess of 5 times 5 times 5 was right. So what does that mean? That means the square root, or I'm sorry, I misspoke. The cubed root of 125 is going to be 5. And that is what x equals. So one of these side lengths here in our box, our cube, is 5. That means all of them are. So to get the volume again, we have 5 times 5 times 5 gets our volume. All right, so that is just clears up cube roots. I'm going to pause it and help us get started in our workbook here. Okay, I think the beginning ones are pretty self-explanatory. We know that we see a square there, so we know that each side length needs to be the same. So these first ones we might be able to get. I want to just go over 7, 8, 9, and 10 real quick, give us a starting point. And it might even help you out with the beginning ones with these starting points. So for 7, it says, what is the sum of the expression? I have the cube root of 64 plus the square root of 64. And I have 4 options, and they're all integers. So I know that these are all going to be perfect cubed and perfect square. So right away, I see the square root of 64. And I already know, oh here, sorry, let me get a good angle. And I already know that 8 times 8 is 64. So if I have the square root of 64, I know that has to be something times something to get it. Well, I know that 8 times 8 is 64. Shut your mouth and say no more is how I memorized it. So I know that the square root of 64 is going to equal 8. And then I have the cubed root of 64, right? We can do the guess and check method just like we did earlier in the video, but we also, I remember at the beginning of the video that we had the square root of 64 as one of our answers. It's when we were multiplying by 4. Remember, we guessed 4, and we got 4 times 4 times 4. 4 times 4 is equal to 16. 16 times 4 is 64. So I know that 64, sorry, I was really close there. 64 is equal to 4 times 4 times 4. Something, something, something. So I know the cubed root of 64, I need what did you multiply 3 times to get it? Well, I multiplied 4 3 times to get 64. So now let's look back in our workbook. We have the cubed root of 64 plus 64. Well, the cubed root of 64 is 4. And the square root of 64 is 8. So 4 plus 8, and you can select which one that is. For 8, it says, for each question, mark the box to indicate whether the equation has one solution or 2 solutions. And these solutions deal with a graph. So I know that if I have a graph with x squared, and this is something we have not gone over yet, it's going to be later in the lesson, but I was going to use this as a way to assess like how well we have learned graphs in the past. But I'm just going over it real quick to help you guys out for this question 8. The equation of x squared is going to look like this. Okay, both of them are going to look like this. For x squared equals 121, x squared equals 49 over 121. Based on the scale, they're going to look like that. And if we have a graph, so I'm just drawing the coordinate grid now. Oops, sorry. We have this x-axis, which is really important in these situations, and our y-axis. The amount of times the equation is going to pass over the x-axis is going to be the amount of solutions it has. So if we see this, I see 1 time it passed through, and 2 times it passed through is our x-axis. That means it's going to give us 2 solutions here. And x squared, 2 solutions there. And then x to the third. When we have x to the third, the graph is going to look like this. So it's not going to curl up like it did. It's just going to wave a little bit. And it's only going to cross the x-axis once. So we're going to have a 1 solution. Question 8 was very hard. We haven't gone over those equations yet. So I understand if you guys are struggling on that. We'll definitely be going over that when we come back from our break here. For number 9, it says write the numbers square root of 50, cubed root of 150, cubed root of 435, square root of 34, square root of 39, and the cubed root of 294 at the approximate locations on the number line. And I see we have 5, 6, 7, and 8. So what we'd have to do is we'd have to estimate what is the square cubed root of each of these, just like we were doing on the previous examples. So square root, we have to multiply 2 things. Cube root, we multiply 3 things. And we estimate what the answer is going to be. I can see all of these are not going to be on the solid integer. So 5, 6, 7, or 8, none of them will be on the actual integer. So that means there's going to be a decimal for all of these. So for number 9, you're going to estimate all of these to the nearest integer and kind of just see if it's closer to 5 or 6, and you can kind of be able to put these in order based on their estimations. And then the same thing for number 10. You're going to estimate each of these, like what number each of these might be, and then compare it to the cubed root of 125. And we did the cubed root of 125 in our example of cube roots on the whiteboard. So we should know what this number is going to be. So once you find out what this number is going to be, you can say if each of these is less than that number, equal to that number, or greater than that number. Okay, and I hope this helped you guys out. Let's see. There's some more of these questions. But for all of these, you're going to be guessing and checking is the best way to solve these cubed root and square root problems. And if you're not getting it, that's totally okay. We're going to go over these more when we get back for more review. I know it's very difficult to learn on your own instead of with a teacher, but we're doing the best we can here. So don't stress out, relax. I want you to at least be exposed to all the lessons, follow the schedule, and do the best you can. All right, guys. I'll see you soon. Hang in there. Keep on asking me questions. If there's anything that you want me to do a mini lesson over, message me on Jupiter, and I will be able to put up a mini lesson on that as soon as I can. Okay, peace out.